Let's say that we have the expression a cos of x plus b sin of x. We can write this in the form r sin of x plus alpha, like this, where r and alpha are constants. It's useful to write it in this form for loads of reasons. It's useful for solving equations, as we'll see in this video, and for modelling, as we'll see in the next video. So how do we actually write it in that form? Well, I think it's best to show you with an example like this one here, where we need to write 3 sin of x plus 4 cos of x in the form r sin of x plus alpha. This is actually the same example that they use in the textbook. It works really well. So for this question, we need the addition formula for sin of a plus b, which is given here. Now, I talked about this in the first video in this chapter. This is given to you in the formula booklet, so you don't have to remember it if you don't want to. You'll have access to it in the exam. Okay, so we need to write 3 sin of x plus 4 cos of x in the form r sin of x plus alpha. So therefore we can say that 3 sin of x plus 4 cos of x is equal to r sin of x plus alpha. What our job is to find the values of r and alpha. Okay, so let's focus on this sin of x plus alpha part here, and hopefully you can see the resemblance between this and the sin of a plus b here, with a being x and b being alpha. So therefore we can use the sin of a plus b addition formula on this here. So we can write sin of x plus alpha in this form. So it's going to be sin a, which is sin x, cos b, which is cos alpha, cos a, which is cos x, and sin b, which is sin alpha. And you can see that in this form here we have this r in front of it, and if we do this, all that this will do is add r in front of both of the terms here. You can also see here that I've written the cos alpha before the sin x and the sin alpha before the cos x, as opposed to this up here. You'll see in a sec why it's useful to write it in this order. So therefore, as 3 sin of x plus 4 cos of x is equal to r sin of x plus alpha, and r sin of x plus alpha is equal to this, we can say that 3 sin of x plus 4 cos of x is equal to r cos alpha sin x plus r sin alpha cos x. So this equation that we ended up with, I've just expanded it up here, and hopefully you can actually see the similarities between the two sides of the equation. We've got this sin x plus cos of x here, and this sin x plus cos of x like this here. The only difference is that on this side we have 3 sin x plus 4 cos of x, and on this side we have r cos alpha of sin x plus r sin alpha of cos of x. So therefore, as these two sides are equal to each other, and these are the only differences, we can compare coefficients and say that 3 is equal to r cos of alpha and 4 is equal to r sin of alpha, as these are the coefficients of sin x and cos of x respectively. And then these two simultaneous equations are enough in order to find the values of r and alpha. So how do we do this? Well, let's start with r, and the way we figure out r is we use a specific method. We add r sin alpha squared plus r cos alpha squared. So we do r sin of alpha squared plus r cos of alpha squared, and then if we expand these brackets, it's r squared sin squared alpha plus r squared cos squared alpha. And we can see that r squared is present in both of these, so we can factorize out the r squared, so it becomes r squared sin squared alpha plus cos squared alpha, and we know that sin squared alpha plus cos squared alpha is equivalent to 1, so this will just cancel out to r squared. And the reason this is useful is because we know that r sin alpha is 4, so therefore this is going to be r sin alpha squared, so it's going to be 4 squared plus r cos of alpha, which is 3, so r cos of alpha squared is 3 squared, and this is equal to 25. So r sin alpha squared plus r cos alpha squared is this, and we know that r sin alpha squared plus r cos of alpha squared is r squared, so therefore r squared is equal to 25, so therefore r is equal to the square root of 25, which is equal to 5. Now you might be wondering about the plus or minus square root. Unless they specifically say in the question, just assume that it's the positive square root and r is equal to 5. Now when you're in an exam, you don't actually need to do this here, because you can see what happens happened is we have this 3 and the 4, the coefficients of sin and cos. We have squared them and added them together to get the 25, and then we have square rooted the 25 in order to get 5. This is the case for every single question that you'll do, such as we can create a formula that r is equal to, so if this is a and this is b, the two coefficients of sin and cos, r is equal to a squared plus b squared, so this is the 4 squared plus 3 squared, and then we just square root it like we've done here. R is equal to a squared plus b squared. This is all you need to remember for the exam. And then when you're in the exam, just write down this formula and therefore say that r is equal to the square root of a, which is 3 squared, plus b, which is 4 squared. And if you put this into a calculator, this is equal to 5, and this is enough. So we found r, so how do we figure out alpha? Well, there's a specific method to do this as well. What we do is we do r sin of alpha over r cos of alpha. It has to be this specific way round, because what happens, so these r's are going to cancel out, so it just leaves us with sin alpha over cos alpha, and recall the identity that tan alpha is equal to sin alpha over cos alpha, so therefore we can rewrite this as tan alpha. And why is this useful to us? Well, the reason this is useful is because we know r sin alpha. R sin alpha is 4 and r cos alpha is 3, so this is 4 over 3, and this is equal to tan alpha, like this here, and therefore we can find alpha. Alpha is going to be equal to the inverse tan of 4 over 3, which if you put into a calculator, specifically want it in degrees to 2 decimal places, if you put this into a calculator, it's equal to 53.13 degrees. So this is what alpha is. Now really quick, there is another way in order to figure out alpha, and what you can do is just take one of these simultaneous equations. So let's take this one here and just sub in the value of r that we got here. So this would now be 4 is equal to r, which is 5, and then sin alpha like this here, and then divide both sides by 5 to get 4 over 5 is equal to sin alpha, so therefore alpha is equal to the inverse sin of 4 over 5, which if you put into a calculator, of course, also gives out the 53.13 degrees. This is a perfectly valid way of doing it. The mark scheme says that it is, and it validates that you can do it like this, and it will give you the marks. The textbook and a lot of sources don't really like you doing it this way, and I think because if you figure out r, and let's say you accidentally figure it out wrong and you get out the wrong answer, because you're using your value of r here, what you're going to do, you're also going to get out your value of alpha wrong. However, if you actually do it using this method down here, because the r's cancel out, you actually still get the correct value of alpha out, 53.13 degrees. This is the slight advantage of doing it this way, is that if you do mess up your r calculation, your value of alpha will still be correct and you'll still get marks for that, which you won't do if you get it this way. So we've figured out r and alpha, so we can write 3 sin of x plus 4 cos of x in the form r sin of x plus alpha. So 3 sin of x plus 4 cos of x is equal to r, which is 5, sin of x plus alpha, which is 53.13 degrees. I just want to make a couple of very final notes. Firstly, I would say more than maybe any other question at A-level maths, there is a lot of very small mistakes that you could make with this question, such that I would write out this whole method here when you're doing this question, and don't rush it. That really reduces the chances of you making any kind of small mistakes that you could lose 1 or 2 marks for. Just also quite interestingly, this is the opposite of the addition formula here. With the addition formula, we're converting this into this expanded form here, whereas with a question like this, we're putting this expanded form back into this form here. So here's another example where we need to write 12 sin of x minus 5 cos of x in the form r sin of x minus alpha. Now, as we have this sin of x minus alpha, we need the addition formula for sin of a minus b, which is given here. Remember, this is given to you in the formula booklet, so you have access to it in the exam. So therefore, we can write 12 sin of x minus 5 cos of x. This is equal to r sin of x minus alpha, which is equal to r, and then sin a, which is sin x, and then cos b, which is cos alpha. I'm just going to write this the other way around. So it's r cos of alpha, sin x, and then this is minus r cos of a, which is cos of x, sin b, which is sin alpha. Again, I'm just going to write this the other way around. So it's sin alpha cos of x, like this. And then again we can see this sin x minus cos x here, and the sin x minus cos of x here as well. So therefore 12 is the r cos of alpha, so 12 is equal to r cos of alpha, and 5 is equal to the r sin of alpha, so 5 is equal to r sin of alpha. Okay, we can figure out r, because remember that r is equal to the square root of a squared plus b squared, where a and b are the two coefficients of sin and cos. So therefore r is equal to the square root of 12 squared plus 5 squared, which if you put into your calculator is equal to 13. So r is equal to 13, and we can figure out alpha by doing r sin of alpha over r cos of alpha, where the r's cancel out, and then sin alpha over cos alpha is equal to tan alpha, and then tan alpha is equal to r sin alpha, which is 5, over r cos of alpha, which is 12. So therefore the inverse tan of 5 over 12 is equal to, if you put it into a calculator, it wants it in radians, the 3 decimal places, so make sure your calculator's in the radians mode, is equal to 0.395. So therefore alpha is equal to 0.395. So therefore 12 sin x minus 5 cos of x is equal to r sin of x minus alpha, where r is 13, and then sin of x minus alpha, which is 0.395. So part B is a very common exam question that comes up a lot. They want us to find the maximum value of 12 sin of x minus 5 cos of x. And as we figured out in part A that 12 sin of x minus 5 cos of x is equal to 13 sin of x minus 0.395, we can make the substitution here, and basically the question becomes find the maximum value of 13 sin of x minus 0.395. And we can do this because if we focus on this sin part here, this part in the bracket doesn't really matter. When you look at the sin graph, the absolute maximum value that sin can have is 1. It can't be any higher than this. So therefore the maximum value that this can have is when sin is 1, and this is going to be 13 multiplied by 1, which is of course 13. So the maximum value of 12 sin of x minus 5 cos of x is 13. And then for the second part of B, we need to find the smallest positive value of x for which this maximum occurs. And as this maximum occurs when sin of x minus 0.395 is 1, what this question is asking is for us to find the smallest positive value of x for which sin of x minus 0.395 is equal to 1, as this is when the maximum is. And if you look at sin graph, you can see that the first time that sin is 1 is when it's sin of pi over 2. This is when it's first equal to 1. So in order for this here to be equal to 1, in order for this to be equal to 1, this here inside the bracket needs to be equal to pi over 2. So therefore x minus 0.395 needs to be equal to pi over 2, like this here, and therefore x is equal to pi over 2 plus 0.395, which if you put into a calculator is equal to 1.97, 2 decimal places. This here is the smallest positive value of x for which this maximum occurs. Of course, this maximum occurs for other values as well, so this maximum also occurs for 5 pi over 2, for example, and 9 pi over 2. This is when sin is also equal to 1. But these will all give, if you rearrange bigger values of x and it wants the smallest value of x, for which is the case. There's of course negative values as well, such as minus 3 pi over 2. Sin of minus 3 pi over 2 is equal to 1, but it says it specifically wants the smallest positive value, and if you rearrange this in order to find x, you would get that x is a negative number. So the smallest positive value of x for which this maximum occurs is 1.97, and this is when it is sin of pi over 2. So in general, these are the three possibilities that you could be asked. This, and this here, with the difference being the minuses or pluses in front of the sin and the cos like this, and then this is the form that you need to write it in. Now, to be honest, I don't think that you need to remember this here, and the reason is because in all of the exam questions that I've seen, like the questions that I've already written in this video, they will tell you in the question which form to write it in, so therefore you don't need to remember this here, it's not necessary. In the really unlikely case that I haven't seen, but in the really unlikely case that they don't tell you which of these to write it in, you still don't really need to remember this because you can work it out using the addition formula that is given to you in the formula booklet. So as x is always the first one in the bracket, therefore it is always the a here. So let's just ignore the b, it's not relevant. So the b's here don't matter. So let's pretend that we're working in this form here and we need to know which form to write it in. Well, we need in the form sin x minus cos of x, and as x is a, we need the form sin a minus cos of a, and we can see that this is this one here. We've got the sin a minus cos of a here, and therefore we use the sin of a minus b and the sin of x minus alpha like this. You can still figure it out using the addition formula in the really unlikely case that they don't just tell you which form to write it in the exam question. So there are two things that they can do with these questions. One, they can ask you an equation afterwards, which we'll go through in this video, or they can do it in a modelling question, which we'll dedicate an entire video to in the next video. So here's an example of an equation question where in part A we need to express 5 cos of x minus 3 sin of x in the form r cos of x plus alpha. Now this is what I was talking about before. You don't need to remember the form that you need to write this in here, r cos of x plus alpha, because it's always given to you in the question like this. So we have the cos of x plus alpha, so we need the cos of a plus b addition formula, which is given to you in the formula booklet. So therefore we can write 5 cos of x minus 3 sin of x, and this is equal to r cos of x plus alpha, which we can write as r and then cos a, so cos x, and then cos b, so cos alpha. I'm going to write this the other way around, so it's cos alpha and cos x like this, and then this is minus r, and then it's going to be sin alpha and sin x like this, and then you can see the cos x minus sin x here and the cos x minus sin x here. So therefore you can deduce that 5 is the r cos alpha, so 5 is r cos alpha, and 3 is the r sin alpha, so 3 is the r sin alpha. Okay, we can figure out r using the formula that r is equal to the square root of a squared plus b squared, where a and b are the coefficients of cos and sin. So r is going to be equal to a squared, which is so the square root of 5 squared, and then b squared, which is 3 squared. And if you put this into a calculator, this is equal to root 34. And then to figure out alpha, we're going to do r sin of alpha over r cos of alpha, which simplifies to tan of alpha. So tan of alpha is equal to r sin alpha, which is 3, over r cos of alpha, which is 5. So therefore alpha is equal to the inverse tan of 3 over 5, which is equal to, so it says it wants alpha between 0 and half pi, so this is indicating that it wants it in the radians form because of this half pi here. So make sure your calculator is in the radians mode, and if you do this it gives out a value of 0.5404. So alpha is 0.5404, so therefore 5 cos of x minus 3 sin of x is equal to r cos of x plus alpha, where r is root 34, and then it's cos of x plus 0.5404, and then that is the final answer. So for part B, we need to solve this equation here. Now, as these are the same question and we've got this part B and part A here, these are most likely linked in some way, and they are because you can see this 5 cos of x minus 3 sin of x is also what we did here, 5 cos of x minus 3 sin of x. And the reason these are linked is this here, we can't really solve this at the moment. There's no easy way to solve this. So what we're going to do is we're going to sub out 5 cos of x minus 3 sin of x for this that we made in part A, the root 34 cos of x plus 0.5404. So this here is going to be subbed out for root 34 of cos of x plus 0.5404, and now this is equal to 4. So we've made the substitution for this here, and this we do know how to solve. We talked about this in year 1. We know how to solve this in the harder trigonometric equations videos, so go back to those if you need to. But to solve these, so we have this inside the function translation here, so that means we need to adjust this interval here. At the moment it's in terms of x, so at the moment it's 0, x, 2 pi like this, and we need to get it in terms of x plus 0.5404, so we need to add 0.5404 to everything. So this is going to become x plus 0.5404, and then this here is going to be 0 plus 0.5404, which is going to be 0.5404, and then this here is going to be 2 pi plus 0.5404, which if you put into a calculator is equal to 6.8236. So this here is the new interval that we're going to work in order to solve this equation. So firstly, move the root 34 onto the other side by dividing everything by root 34. So this becomes cos of x plus 0.5404, which is equal to 4 over root 34 like this. And then firstly, we're going to take the inverse cos of 4 over root 34 using our calculator. It wants the answer in radians because this 2 pi indicates that the interval is in radians. So if your calculator is in radians mode and you put this into your calculator, you get an answer of 0.815. So then what we do is we draw a quick cos graph like this. Now we don't do it in this interval here simply because these numbers are a bit too specific and it's a bit awkward to draw it in this interval. Instead what we do, expand the interval like this. This from 0.5404 to 0, and this from 6.8236 to 5 pi over 2, so it's a lot more of a clean cos graph to draw. The only issue with doing it like this is there are some solutions that may look like solutions in this expanded interval and on the graph like this, but in the actual interval they're not solutions, and we'll see how to deal with this in a sec. Again, if you need a reminder of how any of this works, I'd also recommend the trigonometric equations involving radians video, where we go over how to do questions like this in radians. Okay, so what we need to do is we say that 4 over root 34 is about here. Again, it doesn't matter where too much, and we can see that in this expanded interval there are 3 solutions like this. Okay, we know how this solution here, this is the 0.815, and we know that the difference between pi over 2 and this point here, which is 0.815, is going to be pi over 2 minus 0.815. Again, if you need any reminder of this, go back to the videos I've already mentioned, and if you put this into a calculator, it's equal to 0.756. So the difference between pi over 2 and this point here is 0.756. So therefore the difference between 3 pi over 2 and this point is also 0.756, and the difference between this 5 pi over 2 and this point is also 0.756. So therefore this point here is going to be 3 pi over 2 plus the difference of 0.756, which if you put into a calculator is equal to 5.468 like this here, and then this point here is going to be the 5 pi over 2 minus the difference, which is 0.756, which if you put into a calculator is equal to 7.098. However, you can see that 7.098 lies in the expanded interval on the graph here, but in this actual interval the highest it can be is 6.8236, and this is bigger than that, so this is not actually a solution. So therefore there are only two solutions on this graph here. This one is not, and the two solutions are when x plus 0.5404 is equal to 0.815, the solution that we got here. This isn't a solution, remember, this is the difference here. So 0.815 and also the 5.468, which is this point here. So these are the solutions in terms of x plus 0.5404, but we need it in terms of x. So what we just do, and we minus 0.5404 from both of these. So x is equal to two decimal places. X is equal to 0.27 and 4.93. So these are the two solutions. X is equal to 0.27 and 4.93. And I've talked about this before. I talked about it in the trigonometric equations involving radians video. A really good way to check your answers, in my opinion, is to sub your x solutions into this equation here. So for example, 0.27, you'll do 5 of cos of 0.27 minus 3 sin of 0.27, and if you put this into your calculator, make sure your calculator is in the radians mode, you get out an answer that is roughly equal to 4. Because we've rounded it to two decimal places, it won't be exactly 4, but you'll get an answer that's roughly equal to 4, and therefore you know that this is a correct solution because this side of the equation is equal to 4. I think it's a really good way to check your answers that I don't think enough people use, and you're able to tell if you've done everything right in your working. So here's another example question from a past paper. So for part A, we need to express sin theta minus 2 cos theta in the form r sin of theta minus a. Now, as we are in the form sin of theta minus a, we need the addition formula for sin of a minus b, which is given here. It's given to you in the formula booklet. So therefore, we can write sin theta minus 2 cos theta and then we can use this here, so it's going to be r, and then I'm going to write the cos b first. It's going to be r cos alpha sin theta minus r, and then it's going to be, I'm going to write sin b first. It's going to be sin alpha cos of theta like this, and then hopefully you can see the sin theta minus cos theta, sin theta minus cos theta. So therefore, remember there is a 1 here, therefore the 1 is equal to r cos alpha like this, and 2 is equal to r sin alpha. So 2 is equal to r sin alpha. Okay, we can figure out r using the formula r is equal to a squared plus b squared square rooted. So therefore r is going to be equal to, so it's 1 and 2, so it's going to be the square root of 1 squared plus 2 squared, which is equal to the square root of 5. It says it wants the exact value of r. And then to find alpha, we're going to do the r sin alpha over r cos alpha, and then the r's cancel out to just leave us with tan alpha like this. So tan alpha is equal to r sin alpha, which is 2, over r cos alpha, which is 1, which we can just write as 2 like this. So therefore alpha is equal to the inverse tan of 2, which if you put into a calculator, it wants it in radians to 3 decimal place, is equal to 1.107. So therefore we can write sin theta minus 2 cos theta as r, which is root 5 of sin of theta minus alpha, which is 1.107, like this. So for part BI, we need to find the maximum value of m theta, and m theta is this function here. Now we see we have this 3 sin theta minus 6 theta here, which is very similar to this, but it's 3 times bigger. So what we're going to do is we're going to rewrite m theta. We're going to rewrite it as 40 plus, and then in the bracket we're going to factorize out the 3 here. So this becomes 3 multiplied by sin theta minus 2 cos theta, and this whole thing is still squared here. This 3 is still squared like this. So we have this sin theta minus 2 cos theta here, which we can sub out for root 5 sin of theta minus 1.107. So therefore this is going to be equal to 40 plus and then 3 multiplied by root 5 sin of theta minus 1.107, and then this whole thing here is still going to be squared like this. Now we talked about this before. The maximum value that sin can have is 1. So as we're trying to find the maximum value, the maximum that this can be is 1 here. So therefore this is going to be 40 plus, and then it's going to be still be squared here, and it's just going to be 3 root 5. As 3 root 5 multiplied by this, which is 1, is going to be 3 root 5, and this is going to be squared here. So this is going to be equal to 40 plus, and then 3 root 5 squared is equal to 45. You put it into your calculator, and this is equal to 85. So the maximum value of m theta is 85 when sin of theta minus 1.107 is its maximum at 1. And then for the second part of B, we need to find the smallest value of theta in this range here in which this maximum occurs. So remember, this maximum occurs when sin of theta minus 1.107 is 1. So therefore sin of theta minus 1.107 is equal to 1, and remember sin is equal to 1, this is in radians. Sin is equal to 1 at pi over 2, so therefore sin of pi over 2 is equal to 1, so therefore this here theta minus 1.107 has to be equal to pi over 2, and therefore theta is going to be equal to pi over 2 plus 1.107. So therefore theta, if you put this into your calculator here, is equal to 2.68. So this is the smallest value of theta, 2.68, in which this maximum of m theta occurs. So part C is a really good question in my opinion. There's a lot of notes to make with this. So we have this function here n theta, which is a fraction, and we need to find the maximum value of n theta. So we have this sin minus 2 cos, which is what we figured out in part A, but the only difference is that this was in terms of theta, but this is in terms of 2 theta. And you might be wondering what the effect of this is. The only effect that this has is it replaces the theta here with 2 theta. A common mistake that I used to make at A level was I used to multiply this whole thing inside the bracket by 2 because it's 2 theta. This is not what happens. The only thing that happens is that the theta is replaced by 2 theta. This number here remains the same. So therefore what we can do is we can make the substitution for sin of 2 theta minus cos of 2 theta in order to rewrite n of theta like this, where we have the 5 sin of 2 theta minus 1.107. We have this power to the 2 here. Don't forget that, that's really important, and we'll talk about why in a sec. Okay, so we need to find the maximum value of n theta. Now, the moment you read maximum, you might be thinking to make sin its maximum. And this works for part B, but this isn't going to work for part C, because this sin is now in the denominator of the fraction. And remember, when you make the denominator of the fraction bigger, you actually make the overall fraction smaller, and we want to find the biggest value of n theta. So we don't actually want to make the denominator as big as we can. We actually want to make the denominator as small as we can to find the maximum value of n theta. So now you might be thinking to make sin its minimum value, which is minus 1. And if this was a normal function where the sin was in the denominator like normal, this would work. The only issue with this function is that we have this power to the 2 here, and this minus 1 will not work. And the reason is because, so if we actually sub in the value of minus 1, it will be this here, so we have this root 5, and then it will be minus 1 here, so it will become minus root 5. And then this is raised to the power of 2, so this is going to become 5, and if you figure this out, this is 2. But if this value was 1 instead, so it would become root 5 times by 1, so it would be root 5 to the power of 2. And this would be the exact same thing, it would be 5, so therefore it would be the exact same output. This power of 2 here makes it, so remember that root 5 and minus root 5 squared are the same value. This power of 2 makes it that there is no difference between minus 1 and 1, so therefore we don't want to use minus 1 either. So this power of 2 here makes it all a bit awkward. So what do? We make this value here 0. So basically this whole thing is going to go away because sin is going to become 0. So this is all just going to cancel out like this. And therefore we're only going to be left with the 5 here. So it's going to be 30 over 5, which is equal to 6. And this is the maximum value of n theta. And then for the second part of C, we need to find the largest value of theta in this range for which this maximum occurs. And as this maximum occurs when this is 0, what this question is asking is to find the largest value of theta in this range for which sin of 2 theta minus 1.107 is equal to 0. Now, because it's actually asking for the largest value of theta, in this range, and also because we have this 2 theta, this question is actually a bit awkward, such that, and this isn't necessary for the other questions like this, like part B II, or like the other example of this kind of type of question that we went through earlier in the video. For this particular example, I'm actually going to treat this a bit like a trigonometric equation, and this range here I'm going to alter it to make it in terms of this, like it's a trigonometric equation that we went through in year 1. So we're trying to solve this here. So it's in terms of this here, so if we multiply everything by 2, it's going to become 2 theta, this is still going to be 0, and this is going to become 4 pi now, and then if we minus 1.107 from everything, this is going to become 2 theta minus 1.107, and then this is going to become minus 1.107, and this is going to become 4 pi minus 1.107, which if you put into a calculator is equal to 11.459. If you need a reminder of how to solve trigonometric equations like this, go back to the harder trigonometric equations video. So we're just going to treat this like a trigonometric equation and solve it. So we draw a quick sin graph like we've done here in this interval. We slightly expand the interval because these numbers are too specific to draw an accurate sin graph. We expand this to minus pi over 2 and this to 4 pi here, and we're looking for when sin is 0, and we can see this is at 4 pi. This doesn't lie in this interval here, this only lies in the expanded interval here, so this is not in this interval here. So we'll do 3 pi, so sin of 3 pi is equal to 0, so this here needs to be equal to 3 pi, so this is 2 theta minus 1.107 is equal to 3 pi, and then move this onto the other side to get that 2 theta is equal to 10.53, and then theta divided both sides by 2 is equal to 5.27, and this is the biggest value of theta in this range. You can check that it is in this range at which this maximum value occurs. Of course, there are other values where this occurs at 2 pi and pi at 0 here, but these would all give smaller values of theta. In this range here, this is the biggest value, and we did this by kind of solving this as a trigonometric equation. So here's one final past paper question for you to have a go at. I've given you the addition formula for cos of A minus B as it's given to you in the formula booklet, so you'll have access to it in the exam. So pause the video, have a go, and I'll go through the answers in about 5 seconds. So for part A, this is just a normal simplifying that we've seen before. So we need to show that this can be written as r cos of 2 theta minus alpha. So we need to use the formula for cos of A minus B, which is cos A cos B plus sin A sin B. So therefore we can write 4 cos of 2 theta plus 2 sin of 2 theta as r cos of alpha cos of 2 theta, I've done the alphas first, plus r sin of alpha and then sin of 2 theta. And then hopefully you can see the cos 2 theta plus sin 2 theta and the cos 2 theta plus sin 2 theta here. And therefore you can see that we have 4 is r cos alpha. So 4 is r cos alpha and 2 is r sin alpha, like this here. Okay, so we can figure out the identities of r and alpha. So r, we can use the formula, which is the square root of a squared plus b squared. So it's going to be the square root of 4 squared plus 2 squared, which if you put into a calculator is 2 root 5. So r is 2 root 5, and then we're going to do r sin alpha over r cos alpha, and the r's cancel out to give us tan alpha, like this. So tan alpha is equal to r sin alpha, which is 2 over r cos alpha, which is 4. So tan alpha is equal to 2 over 4, and then the inverse tan of, 2 over 4 is a half. The inverse tan of a half is 26.57, and this is what alpha is. So therefore we can write 4 cos of 2 theta plus 2 sin of theta as 2 root 5 cos of 2 theta minus 26.57. And then for part B, we need to solve this equation here. And as we have the 4 cos of 2 theta plus 2 sin 2 theta here, we can make the substitution which we found that it was in the first part, which is this here. So we can rewrite this using the substitution as 2 root 5 cos of 2 theta minus 26.57, and this is equal to 1. And then divide both sides by 2 root 5, so it's cos of 2 theta minus 26.57 is equal to 1 over 2 root 5, like this, and then we can solve this. So firstly, we need to expand this interval, and at the moment in terms of theta, we need to make it in terms of this here. So firstly, we're going to multiply everything by 2, so it becomes minus 180, 2 theta to 180, and then we're going to minus 26.57 from everything, so this becomes 2 theta minus 26.57, and then minus 180 minus 26.57 is minus 206.57, and then 180 minus 26.57 is 153.43. So this is the new interval that we're working in. Okay, so firstly, let's take the inverse cos of 1 over 2 root 5, which if you put into a calculator, we need it in degrees. So put your calculator in degrees mode, gives out 77.08 degrees. And then we draw a quick cos graph here. I've slightly expanded the interval from this to minus 270 and this to 180, so it's easier to draw. And we'll say that 1 over 2 root 5 is about here. So we can see that in this interval there are two solutions. We already know this one is the 77.08, which our calculator gave us, and because the cos graph is symmetric along the y-axis, this one here is just going to be minus 77.08, like this. So therefore the two solutions, so 2 theta minus 26.57 is equal to minus 77.08 and 77.08, and we can see that these both lie in the interval here, and these are the only two solutions. So therefore 2 theta is equal to, so we add 26.57 to both sides, and we get minus 50.51 and 103.68, and then we divide everything by 2 to get that theta is equal to minus 25.3. It wants it to one decimal place, and 51.8 degrees. So for part C, we're introduced to this equation g theta is equal to k, and as g theta is equal to 4 cos of 2 theta plus 2 sin of 2 theta, and we can write this in this form here, therefore we can write g theta is equal to k as 2 root 5 cos of 2 theta minus 26.57 degrees is equal to k. So g theta is equal to k is this here, with this being g theta. And we are told that this has no solutions, so therefore we need to find the range of possible values for k. So what it's asking us is, this has no solutions, so therefore what are the possible values of k? Well, firstly, let's divide both sides by 2 root 5s, so this becomes cos of 2 theta minus 26.57, and this is equal to k over 2 root 5. So when does this have no solutions? Well, cos here, this bit doesn't actually really matter at all. cos in general only has values between -1, it can equal -1 as well, and 1. If you want to be more specific, cos of 2 theta minus 26.57 only has values between -1 and 1. So therefore there are no solutions to this equation here if k over 2 root 5 is bigger than 1, or k over 2 root 5 is less than -1, because this here, cos of 2 theta minus 26.57, this side of the equation can only be between -1 and 1. So therefore, in order for there to be no solutions, this has to either be always bigger than 1 or less than -1, like this. And therefore, we can just multiply both sides by 2 root 5 here. So this becomes k is bigger than 2 root 5, or k is less than -2 root 5, and this is the answer. The range of possible values of k for which there are no solutions to this equation here is when k is bigger than 2 root 5 or k is less than -2 root 5.